in 2020. I'm happy that all of you decided to join this session called Normalization Beyond the Normal Form. I am joined today by Lewis Davidson, who will be my moderator. So he will be watching the chat window and the questions tab. And if there are any questions for me or any remarks that I should address, he will read them to me, and then I will try to respond as good as I can. Now, there is a small delay on the stream, so the questions will not pop up immediately for Lewis and me, but that means that you might need to provide a bit of context so that we know what part of my presentation your question is about. Before I get started, I do want to point out that you are now at the PAS Summit, and that's what PAS is most known for, but it's not the only thing PAS does. PAS offers a lot of things for the community, mostly funded by this event, and all of the things they do are worth your time investigating. So do explore everything PAS has to offer, but not now. Now you're going to listen to me. And after you're done listening to me, I really would like you to go to the session evaluation link and let me know what you thought about this session. Of course, I enjoy a nice compliment, so if you like my session, let me know. But I also want to get better at what I do. So if you didn't like my session, that's the feedback that's most relevant for me. If you add why you didn't like my session, if you just say it was humbug, then I can't act on that. If you tell me what I did wrong, I will try to improve for future deliveries of this and other sessions. My name is Hugo Kornelis, and I make SQLServerFast.com. SQLServerFast.com is a website where I am building a lot of documentation specifically about execution plans. Execution plans is a favorite subject of mine, but it's not my only favorite subject because I'm talking today about database design. So we won't spend much time on execution plans now. I do have a lot of other stuff on my website as well. Most important, that was too fast. Most important, as you see on the bottom, the deck and the demo code. There is no demo code for this session. This is a boilerplate slide. So the deck for this session and the deck and demo code for other sessions are all available on SQLServerFast.com. I have a lot of other stuff in my life going on as well. You don't care about that. You're not here to learn about me, but you do care how to reach me through email and through Twitter, and how to download the slide deck for this presentation. You may notice that there are some small changes if you compare these slides to the ones you download, and that's because I rearranged some of the slides so that my head doesn't obscure important details on the slides. So we are going to talk about database design and about normalization. And when I talk about this subject, I often get people who say, why do you care? Why do you bother? Normalization is boring. No, it isn't. You may think it's boring, but in reality, it's fun. Normalization can be made boring by using boring examples, by using boring language, but I'm going to try to make it fun and to make it accessible. And then people say, oh, normalization is hard. It makes my head hurt. That depends on how you explain things. It's actually easy, but in the academic world, there is this idea that everyone should use inaccessible terminology and make it as complex as possible, where in reality, many of the concepts aren't that complex if you get to the bottom of it. So I will try to simplify everything today without bending reality. It will still be correct what I teach you, but not as hard as you're used to. And then there are people who say normalization isn't important. Who cares? And to those I say you are absolutely wrong. Normalization is very important because normalization can help you prevent storing nonsense in your database. And we'll see examples of that as well. So for today, the schedule is, and this session has kind of a flexible schedule because sometimes it's scheduled for a 60-minute delivery, sometimes for 75, and sometimes for 90. And that determines how much I can do. So the overall agenda is we're going to talk about key concepts. We're going to talk about normalization up to third normal form, and then the main part of this presentation beyond third normal form. All the higher normal forms, AKNF, BCNF, 4NF, 5NF, DKNF, ONF, and 6NF. Yes, I have practiced that. However, we have 75 minutes. Now, you need to be aware that normalization up to third normal form, that is usually the first semester in college. And the higher normal forms, that's normally the second or third semester in college. So obviously you are a bit smarter than college students. Normalization up to third normal form would take me the 15 minutes I don't have. So I'm going to skip those 15 minutes so that I finish in 1 hour and 50 minutes. The higher normal forms, we're going to do an entire semester in just 1 hour. And of course, we're going to start with the key concepts. And trust me, it sounds insane doing a complete college semester in one session. It's possible. So we're not going to talk about normalization up to third normal form. I'm going to assume that the basics of that are known. But I am going through the key concepts to make sure that we are on the same page terminology-wise. A very important term that I always use when talking about database design is the universe of discourse, the part of reality or of a virtual reality, if we're, for instance, working on a virtual game, the part of reality that is relevant to the business and as seen by the business. Now, when I am at a customer on a Zoom call or once this pandemic is over in their offices and we're at the coffee maker and we're discussing soccer or our kids, then we can discuss everything we want. But as soon as I'm on the clock and I'm doing work, I'm only interested in the part of reality that's relevant to the business. And unless I'm working for the soccer league, soccer is not part of the universe of discourse. It's part of reality, but it's not part of the universe of discourse. And when I say as seen by the business, and I'm deliberately going to use a rather contentious example here, you have to do what the business wants. So the example I'm going to use is, let's say I am working for a wedding planner and they want a database and they tell me that for them, marriage is only valid between a man and a woman. I personally completely disagree with that. I'm not going to discuss that. It's just a personal opinion, and I know that other people have other discussions, but it is, of course, a contentious subject. When I'm working for that customer, they pay me to build their data model. So at that point, I have two options. I can say this is so against my principles, I'm not doing this. Then I have to quit the job, walk away, and not take their money. But as soon as I am prepared to take their money, I need to build what they want and not build what I think they want. Now, in reality, there are, of course, discussions possible where I tell them about the potential customers they might miss and the potential negative publicity they might get. But in the end, if they say, this is how we want to do business, we are the business owners, this is our choice. My choices are walk away or build what they want. I should never build what I want if they want something else, because then I'm not doing my job properly. So the universe of discourse is the subset of reality as the business sees it. And when we're doing our job, whatever is not in the universe of discourse is completely irrelevant. Now, when we talk about normalization, why do we normalize? And when I ask this, I often get the answer, well, we want to prevent the database storing data that is incorrect. Here's the thing, you can't. Let's say I go to an online dating website right now. Don't tell my wife, but by the way, it's just an example. Let's say I go to an online dating website right now and I make a profile and I upload my profile picture. Yeah, this wouldn't work, but if I remove myself, how would the website ever be able to notice that I am not being completely honest with them? How would the website know that? They can't. So they cannot prevent this data, even though it's incorrect. But that's impossible for a computer to do. What a computer can do is prevent data that is impossible, inconsistent, or in violation of business rules. So, for instance, if I would enter a date of birth in the 17th century, that would be impossible, and they would never allow that. If I upload this profile picture and supply my real date of birth, then it would be inconsistent, and with proper analysis of the picture, they could conclude that this is an impossible combination. It's inconsistent. And if I enter my date of birth as 2010 on a dating website, it's in violation of business rules because I'm not 18 yet according to my given date of birth. So those are the kind of rules that normalization can prevent. And obviously there are other ways to prevent that, but if you do it by normalization, then the database does it for you and you get it for free. And there is no way that anyone can ever get around it, even if there is an error in the application. So that's why it's very important to normalize your data as good as possible to prevent as much as possible impossible, inconsistent, or data in violation of business rules. Give me my mouse back because I need focus here. Yeah. So when you talk about normalization, the normal forms, and most of you know first, second, and third normal form, we're going to talk about it many more later, are defined per table. So people often say, is this database normalized to third normal form? That's actually a sloppy way of saying, are all tables in this database at least third normal form or better? Because every table can be defined as its own normal form. And if you talk about the database or the schema, then you're actually talking about the lowest normal form of all tables in that schema or in that database. If you want to, the button you see here, I'm going to ignore it. That's to skip some of the key concepts, but we have time for that. So I'm not going to skip that. There will be another button later that I will press. Are there any questions, by the way, at this time, Louis?
No, there's not.
Good. Then let's continue. The next key concept I want to talk about is the functional dependency. A functional dependency is extremely important to understand what a functional dependency is, because functional dependencies are at the root of most of the parts of normalization. So a functional dependency means that column A determines column B. That's another way to say the same thing. And that is the case. Column A determines column B if for each possible value of A, there is either one value for B or none, but never more than one. And that's very important, that there can never be more than one. So some examples, and many of the examples I give here are based on conferences, but they're actually based on live conferences. So we're going to talk about chair numbers and badge numbers. And I know that in this virtual conference, it's a bit different, but let's assume we are actually at a live conference and I'm in my room and you are in my room and the chairs are numbered. Now, if I look on a given chair, it can be empty. Then there's no attendee on that chair. Or there can be an attendee there, and I can get the name of that attendee and the birth date, and it will never be more than one. Well, except if we get really cozy and people start sitting in each other's lap, but let's assume that the business rules don't allow that. So nobody is sitting in each other's lap. Every chair has at most one attendee. So given a chair number, I can give you the name, or I can tell you there's nobody there. I can give you the birth date or tell you there's nobody there. But given the birth date, I cannot tell you the name. Because even if it's a very small room and there's just 10 people there, even with this very small audience, there's always a non-zero chance that two people happen to have the exact same birth date. Those two people probably do not have the same name. So that's not a functional dependency. Given that birth date, I cannot tell you I have nobody in my room who was born on that date, or I have one person who's called like this, because the answer might be I have two people in my room and these are their names. That's two values. So in terminology, functional dependency has a lot of different ways to say the same things. So if we, for instance, talk about the functional dependency of between badge number and name, in a conference where people have badges that have a unique number, the name depends on the badge number, or the badge number determines the name. That all means the same. And the short form in which this is sometimes written is badge number arrow name, which means badge number determines name. There's a functional dependency where badge number determines the name, where the name depends on the badge number. I'm going to use all these terms interchangeably as well. The term functional dependency itself is often abbreviated to just FD in literature that assumes that you know the context that FD is a functional dependency. Now, the example so far was simple functional dependencies, but you can also have composite functional dependencies. And a composite functional dependency means that a combination of A and B determines C. So if this is true, if for each combination of A and B, there is either one value for C or no, but never more than one. Basically the same definition as the simple functional dependency, but now we're talking about combinations of A and B. So let's return to our example of the conference. I was talking about my room, but the conference has multiple rooms, and there's a chair 15 in my room. There's also a chair 15 in someone else's room, and there's probably another attendee sitting on that chair 15. So if you don't limit your universe of discourse to just my presentation, but you expand the universe of discourse to the entire conference, then there's a functional dependency of the combination room number and chair number determines the name. Then there's a thing that I call cheating functional dependencies. And yes, that's not the official terminology you will see in academic literature, because academics like to be complex and like to make it hard. I like to make things simple. And I call it a cheater because now you'll understand what it is. So let's assume that we have a functional dependency where the badge number determines the name. I know a badge number, I can look up who has that badge. Now that person is probably sitting in a chair. So if you give me a badge number and a chair number, I can tell you the person with that badge number is on that chair number, that's his name. Or maybe that person is sitting somewhere else. And then that combination is an invalid combination. Then there's no name for which that combination is valid. But again, never more. Because badge number by itself already limits me to one name. The combination of badge number and chair number can never give more. That's quite obvious. So that's why I call this a cheater. Yeah, if you follow the rules, you will find, oh yeah, this follows all the rules of a functional dependency. So it can claim, I'm a functional dependency, but it's cheating because you can just remove chair number from the equation, and that's the real functional dependency that you should be looking at. So we never look at those cheater functional dependencies. Now, if you have composite one way around, you might have composite the other way around. So maybe attribute A determines the combination of attributes B and C. Now, it turns out that we don't need to look at that, because if A determines B and C, then it's always true that A determines B, and also A determines C. So we never need to look at this complex version. We only are interested in compositeness, is that the word? On the left side of the arrow. And that means that if you have composite on both sides, you can still split at the right side. So if the combination A and B determines the combination C and D, you can simplify that, just say the combination A and B determines C, and the combination A and B determines D. And that's it. Now, once you know what functional dependencies are, you can define the concept of a candidate key. A candidate key is defined within a table. A lot of normalization stuff is always within a table. And a candidate key is either a single column or a combination of columns. And you will see above me in the example that I use arrows above the columns. That's not a standard notation, but it's a notation I picked up many years ago when someone taught me about this stuff. And I like it, so I always use it because it's a very nice visual indication. Let's do the last point. So a candidate key is a column or combination of columns is a candidate key if it determines every other column in the table. And one very simple way to remember this is if you use this arrow notation, that every arrow means below me there are no duplicates. And that works. In the example above me, there's also no duplicates in the name column, but that's just a coincidence. It can happen that there are no duplicate names, but that's not a guarantee. The functional dependencies and hence the candidate keys talk about things that are guaranteed in the universe of discourse. Now, in the table, you can have, as we already saw, multiple candidate keys. That's why they're called candidates. Just as when you're doing an audition for a huge Broadway production and everyone wants to have the lead, everyone wants to be the primary, but only one gets chosen. And just as with a Broadway production, they will also need alternates. Okay, the example falls a bit flat here, but this is how it works. If you have a table, you have more than one candidate key, you have to choose one to be the primary, and the rest is automatically an alternate key. And if you're working with SQL Server, then the primary key will be defined with a primary key constraint, and the alternates are defined with a unique constraint. Now, I am going to skip the part on the first 3 normal forms because we have 75 minutes and not 90. But this is included in the slide deck. So if you download the slide deck, you can review that part later. To summarize the part I just skipped, a table is in third normal form if every non-key column depends on the key, the whole key, and nothing but the keys. So help me God. I didn't come up with this joke myself. It's a widely spread meme, but it's a very easy way to remember third normal form and a very easy way to check it. Now, there's also a thing called Bernstein's algorithm for synthesis of a third normal form schema. And what this is an algorithm, the name says it, where you start by finding all the functional dependencies, the real ones, not the cheaters. You take all the real functional dependencies, you put them into the algorithm, then you follow all the steps, and the result is a collection of tables that is guaranteed to be in third normal form. And this is mathematically proven to be correct. The weakness of this part is that it only works correctly if you start with every functional dependency. If you miss just one, you might already be wrong. So I personally try to typically use other ways to get at a third normal form schema. So it's time to talk about the actual subject of today, unless I think this is a great time to again ask Lewis if there are any questions.
There are none. No.
None. Okay, well, I'm very clear apparently. So we are going to talk about all the higher normal forms, and I've listed them here, but I'm not going to go through them in order. I am actually going to skip EK elementary key normal form for now, and I'm going to start with Boyce-Codd normal form. I will return to elementary key normal form later because that's easier to explain that way. So let's start with Boyce-Codd normal form. And Boyce-Codd normal form is actually a small extension of third normal form. So remember, third normal form, every non-key column depends on the keys, the whole keys, and nothing but the keys. Boyce-Codd normal form is simply someone saying, going over there and saying, hey, why is there an exception there that non-key columns have to fulfill this requirement of depending on the keys, the whole keys, and nothing but the keys? But there's also key columns, and they can just do whatever they like. We have no rules for key columns. Let's remove that. And that's Boyce-Codd normal form. Every column depends on the keys, the whole keys, and nothing but the keys. That's the entire definition. Why is this distinction important? Why should we care? Let's look at an example. So again, this is based on the idea of a physical conference where when there are tracks and sessions and they're in rooms. And one thing I need to point out, I actually borrowed the notation of tracks and session numbers from previous past summits where this way of numbering sessions was used. And one of the things I skipped when I talked about the first 3 normal forms is a discussion on whether you should have a session 8205 as an atomic data or whether you should split it as a track and a session number. And that depends on the universe of discourse as well. If you need to do some logic specifically for the track, you need to have it separated. If you only use it as 8205 is a session and you never look at the components, then it's simply a single column. Same for instance, the hour and the minutes in the start time. I'm never interested in just the minutes or just the hour. So start time, 10 o'clock or 12:45 is perfectly fine as atomic. But apparently in this universe of Discord, of course, I am interested in having track AD and session number 207 separately. So this is a part of the schedule, and every session is planned in a room and at a time. Makes sense. And the candidate keys make sense as well, because every session is programmed only once, and we don't want 2 sessions to go on in the same room at the same time. That would be very confusing for the audience. So just looking at this table, I can already conclude, I see the keys, I see the other columns. I can already conclude from looking at the tables, because every key is a functional dependency for everything else, that apparently room depends on the combination of track and session number and everything else. You can read it from the slide. But there are some cheaters here, because in reality, and that's specifically for this universe of discourse, and that's something I didn't share with you yet, But the organizers, when I started doing this gig, the organizers told me, we want it to be easy for our attendees. We have attendees who just want only AD sessions or only PD sessions or only BI. We don't want them to have to switch rooms all the time. So we have a simple rule that all AD sessions are in the blue room and all BI sessions are in the room 605. And we have exactly as many rooms as we have tracks. So track by itself already determines the room, and room by itself already determines the track. And because of that, track plus session number determines the room is a cheater, and room plus start time determines the track is also a cheater, because you can just remove one of the elements there and still have a correct functional dependency. Now for third normal form, this is not interesting, because there are no non-key columns, and third normal form is only interested in non-key columns. If there are no non-key columns, then by definition third normal form cannot be violated. But Boy's quad normal form is different. Boy's quad normal form says every room, every column has to depend on the keys, the whole keys, and nothing but the keys. But track depends on the keys. It depends on nothing but the keys, but it doesn't depend on the whole keys. Track doesn't depend on the combination room and start time. It depends on room only. Now, when we did this in the part I skipped for a second and third normal form, we realized, okay, if there's other functional dependencies, we need to, oh, I skipped the part. So, and that's actually the fun part, because why is this relevant? This design doesn't look bad, right? Many people will look at this design and say, yeah, okay, it's not Boy's code normal form, but who cares? It's still correct. It isn't. That's the problem. I can go in, enter into the admin system, and reschedule session PD203 to be in room 605. The resulting data is still completely correct according to the functional dependencies, according to the keys that we have laid out here. But I am violating a business rule, because now room 605 suddenly has a PD session and a BI session. And some of the PD fans will need to switch rooms, even though the organization told me they don't want that. So that's why Boy's quad normal form is really relevant, because third normal form allows this. Boy's quad normal form doesn't. And if you want to fix things like that, the standard option is to say, okay, I have this functional dependency. For this functional dependency, I'm going to break it out in a separate table. And in this case, because it's a mirrored functional dependency, it would be a small table with two columns that each are a candidate key. And normally we would now remove one of the columns from the table on the left side, but because there are two keys, we actually can choose which of the columns to remove. And this is a completely arbitrary choice. I don't care which one you choose. For my slides, I've chosen to remove the room column. And I don't need to store that anymore, because that will be redundant to store it in both tables. So I can remove that, but now I have a problem with the candidate key over room and start time. I still want to enforce that candidate key, but the room column has been removed. Luckily, there's a one-to-one relationship between room and track. So the candidate key over room and start time is actually completely equivalent to a candidate key over track and start time. And in fact, if I had done my work properly, I would never have missed this candidate key, because this candidate key was here all along. I just had missed it because it isn't as logical as the other ones, but it's still there. And now that I have done a safe replacement for the candidate key that needed the room column, I can actually remove it. And this would be the Boy's code normal form schema for this universe of discourse. Now, there's one issue with Boy's code normal form, and that's that it's sometimes not possible to achieve it. So I have changed the data slightly. It's the same conference, but they had to scale down. They only have 3 rooms, even though they still have 4 tracks. So what they did is they said, okay, for the DBA track and the PD track, we don't have as many sessions. We will do both of them in the grand room. Then we will still have the blue room for AD and the 605 room for BI. So now there is still a cheater functional dependency in the table you see, saying that track and session number determines room, because it's still true that track determines room, but room no longer determines track. So room doesn't determine track. That's no longer a violation of Boy's code normal form, but track still determines room, and that is a violation of Boy's code normal form. So we need to fix this one as well for this UOD. And that's the same steps as we did before, right? So we create a new table, now with just a single candidate key, and then there's no choice which column to remove. We need to remove the room column. And oh, wait, how are we going to handle the candidate key on room and start time now? Now it gets harder. The trick we used before is no longer correct, and I'll show you why. If I would use this trick, I could reassign DBA 305 to start time 1430. And if you look at just the table on the left, you will see that all the candidate keys there are completely respected. There is no violation here. In the table on the right, there is no violation either. But if I combine the data, I would still end up with Steve Jones presenting DBA 305 and Tim Ford presenting PD 203 in the same room at the same time. Imagine those two fighting over the microphone to see who gets to deliver their content. Imagine splitting the screen in half between their presentations. That's not really what the conference organizers wanted. So this is not a good solution. Can we return to the original form and then just accept that the room column is there twice? Well, we can, but yeah, I can now still reschedule PD 203 to room 605, which would be a violation of another business rule, because we wanted the PD sessions to all be in the grand room. There is no way to fix this in the official relational model. There is a way to fix this in implementations such as SQL Server, because in SQL Server, I can define a foreign key constraint on the combination of track and room in the left table that addresses track and room in the right table. And if I try to do that this way, I will get an error because there is no primary key or unique constraint on the combination of track and room in the right-hand table, but I can declare that, and that will be a cheater of uniqueness because track by itself is already unique. And if you just look at that, it's like, why the heck did someone define that in order to enable this foreign key? So this is a workaround. It's not completely relational, and the relational purists will hate you for it, but it is a workaround where you can still enforce all the business rules, even in a case where Boycott normal form is not achievable. Any questions so far? Louis? Louis? He'll wake up eventually. He is probably falling.
I'm sorry, I couldn't get it to unmute. No, there's no question at this point.
Okay, sorry for my jab at you. I was joking. I didn't really assume you were asleep, but I couldn't help myself. I had to take a jab at you. Anyway, that was Boycott normal form. Let's move on to elementary key normal form. That's the normal form I hate the most, because every time I do this presentation, I have to go through the same research paper again to refresh how it works. And there's a single research paper on this normal form. It's like 6 pages PDF, and it takes me 7 hours to read and digest. And then 2 weeks later, it's all gone again because it's hideously complex written for a key normal form that is probably the least relevant of all. So let's try to understand what elementary key normal form is. Elementary key normal form is, well, we talked about third normal form. Every non-key column depends on blah, blah, blah. We talked about Boycott normal form. Every column depends on blah, blah, blah. So what's elementary key normal form? Well, every non-elementary key column depends on the keys, the whole keys, and nothing but the keys. So instead of having an exception for all the non-key columns, elementary key normal form only has an exception for key columns that are not elementary, dear Watson. So yeah, nice definition. What is a non-elementary key column? Well, let's reverse it. What is an elementary key? So an elementary key is a key that is based on elementary dependencies. Yeah, dude, that doesn't help me. Okay. An elementary dependency means that this is specifically relevant for composite dependency. So you have a functional dependency where the combination of A and B determines C. This one is not elementary if C determines A or C determines B. That's basically the example we just saw, where we had track and session number determining the room, but room in itself determined the track already. So that was not an elementary key. All other dependencies are elementary. So there's a small group of dependencies that are exceptions that are considered not elementary. All the rest is elementary. And if a key implements at least one elementary dependency, then that key is an elementary key. And then elementary key normal form is just third normal form, except for columns in non-elementary keys. That's where it moves to the rules of Boyce-Codd normal form. Why is this relevant? Not really. Academics like it because it's the highest normal form that is guaranteed achievable. Boyce-Codd normal form is easily proven to be not achievable just by giving a single example. I already did that. Proving that something is guaranteed achievable is much harder. It takes a lot of mathematics and set logic, but one can prove that this form can always be guaranteed achievable. In fact, it's even proven that if you follow Bernstein's algorithm for synthesis of a third normal form schema, the result is not third normal form, but elementary key normal form. Bernstein didn't know this because elementary key normal form was developed and designed later. But how relevant is this? When I have a table that violates BCNF and I can solve it, then I can say, oh yeah, but it's still elementary key normal form. I don't violate elementary key normal form, but I still have the issue that, as I showed, there are two ways to solve it, and both allow for some bad data to be stored in the table. We didn't want that, but we couldn't fix that because Boyce-Codd normal form didn't address that issue. So there are cases where you simply cannot achieve Boyce-Codd normal form, even though you would want to. Elementary key normal form is basically saying, yeah, we can fix it, so let's give it a name and then it's acceptable. Unless there's questions, I'm going to move on to fourth normal form.
Okay, there are two questions.
Oh, nice.
First, what is the name of the EKNF paper from Jonathan D?
I'd have to look that up later. I can't give you that now.
Okay.
If anyone wants to see that paper, they can drop me an email and I will dig up my link and share it with them and send them my commiserations a week later after they have tried to digest it.
Okay, and the other question goes back to the previous set where we were talking about Boyce-Codd. It said, why did you leave the room in the first table at all?
Sorry, what was the question?
Why did you need to leave the room in the first table at all?
In Boyce-Codd normal form, you didn't need to leave the room in the first table. Once you had a new table with only room and session, let's quickly go back. This is for, yeah, once you have this table on the right-hand side, you this is then for elementary key normal form, but I see even that the heading is wrong. But as soon as you have this table where you can find the room based on the track, you technically don't need the room column in the left-hand table anymore because you have the track there. And based on the track, you can find the room in another table. So storing it in two tables would be redundant. And for Boyce-Codd normal form, it is perfectly fine to remove the room. For elementary key normal form, it is not, because in this second universe of discourse, where I changed the rules a bit, I can remove the room from that table and I do not lose information, but I do lose the power of the key, the candidate key over room and start time, because I would have to throw away that key. Does that make sense to you? I know I can't ask the audience, but does that make sense to you, Louis, the way I explained this?
I think so. I'm gonna have to go back and watch it because I'm watching this. Make sure there's no more questions before we move on.
Okay.
So there's no more questions right now.
Good. Let's move on to fourth normal form then. And for fourth normal form, I'm going to assume that the conference we're at is a multi-day conference, and they have decided during lunch hour we're going to have an Ask the Expert booth, where some well-known MVPs take turns manning the booth, and they all have their subjects that they want to talk about or that they feel that they can talk about. Then on the screen you see a table of who is assigned to what subject on which day. And in this table, there's simply a candidate key over all 3 columns. If you check the data, you will see that that is actually correct, according to the rules of third normal form, elementary key, and even boycott. This table is just completely boycott normal form, nothing wrong here. But fourth normal form is yet another step. So to understand fourth normal form, you first have to understand that if you just look at the table, it's not data, it's facts. Every row in a table is a collection of facts. For instance, the top row here, it tells me that on Monday, I can ask Erland questions about design. And here's the thing, just looking at that fact alone, on Monday, I can ask Erland about design. That fact actually contains 2 other facts. So by knowing that I can talk to Erland about design on Monday, I can infer that apparently I can ask Erland questions on Monday. He will be at the booth. And apparently Erland knows about design, or thinks he knows about design, and has signed up to talk about that. Now that's all quite obvious. Of course, on Monday you can ask Erland about design. Of course, you can infer those 2 facts. But how about the other way around? What if we remove everything from the slide except those 2 sentences? On Monday you can ask Erland questions. Erland knows about design. Can we now infer that I can ask Erland about design on Monday? You might say, yeah, of course, he's there and he knows about design, so why not? Well, universe of discourse. It depends. It depends on what the rules are. What if Erland says when signing up for his booth duty, hey, I know a lot about design, I know a lot about tuning, and I'm here on Monday and I'm here on Tuesday, but please, no design questions on Monday. Why not? Well, I don't like Mondays. Who needs more reason than that, right? Now, if the conference says, okay, Erland, I don't understand why you want to have this exception, but sure, it's your call. If you don't want to talk about design on Monday, then we'll just remove that row from the table. Then that means that on Monday, I can still ask questions on Monday from Erland, if it's about tuning. Erland still knows about design, and I can even talk about it with him on Tuesday. But I cannot talk about design on Monday with Erland. That row has been removed. If this is the case, then there's nothing wrong with this table. The table is perfectly fine. It's in fourth normal form. But what if the conference organizers say, Erland, we're not going to do that. We're not going to cater to every wish of an MVP who thinks they're more important than the attendees. If you sign up for Monday and you say that you know about design, then you just have to take those questions. If you don't want to talk about design on Mondays, then either just don't come at all on Monday or remove design from your name tag. We're fine with either choice. But if you have design on your tag and you're here on Monday, then you can't refuse to talk about that. That's another choice the conference organizers can make. It's another universe of discourse. And if that's the choice, then we have a problem in this table, because you already saw it happening. Erland refusing to talk about design on Mondays requires the removal of exactly 2 rows and not 1. It's weird. We removed 1 fact and we had to remove 2 rows. The problem is that our table is wrong. We should have looked at the individual facts. On Monday, you can ask Erland questions, and Erland knows about design. Those are 2 separate facts, and they should have been stored in separate tables. And if you have those separate tables, then you can just join them to get the table on the left-hand side, which should be in a printed guide or something. But the actual base data is there. And now Erland can choose, do I not talk on Monday? That's 1 fact removed from 1 table. Do I not talk about design? That's 1 fact removed from another table. And in both cases, there will be 2 facts removed from the view or report or whatever you call it. So here the original table was in fourth normal form. Now let's go to the formal definition. If you are thinking about fourth normal form, we're talking about tables that are already in Boyce-Codd normal form. And then to be in fourth normal form, the additional requirement is that there are no multi-valued dependencies between subsets of columns. Now I highlighted two terms here. The subsets is simply because once you understand multi-valued dependencies, you will realize that if you look at all the columns in the table, there is by definition a multi-valued dependency. We don't care about that. We only care about multi-valued dependencies between subsets. The second highlighted term is multi-valued dependency. And what is a multi-valued dependency? It's not a special case of a functional dependency. Actually, a functional dependency is a special case of a multi-valued dependency. So for a multi-valued dependency, you can say that column A multi-determines column B, notated with a double arrowhead, if for each possible value for A, there are 0 or 1 or more values for B. Now that sounds kind of obvious until you add regardless of values in other columns. Let's look at some examples. If you look at, for instance, this specific virtual path summit, this is an example that actually works for our virtual summit. I do not have access to the information, but someone with access to the information could grab an attendee list of everyone watching this session right now. So given the session normalization beyond third normal form, we can get a list of all the attendees that were there, 0, 1 or more. By God, I hope it's more than 0. 0, 1 or more. And it's not dependent on something else. But given the presenter, my little person, Hugo Kornelis, you cannot do the same, because today I'm talking about normalization. Tomorrow I will be talking about execution plans. So if you want to know which attendees listened to me this past summit, that answer depends on whether you want to know which attendees listened to me during this presentation or which attendees will listen to me tomorrow. That will be a different list. So presenter does not multi-determine attendee, but session does in this universe of discourse. Of course, in other universe of discourses, it changes. I have done the same session before at other conferences. And then there were other people in the audience. So if you widen the universe of discourse to not be only about past 2020, but about all the conferences ever given in the world, then the combination of conference and session multi-determines attendee. I can still give you an exact list of attendees that attended this conference at past summit 2020. But I cannot give you a single list of attendees who attended this conference, this session, because that depends on which conference, which delivery. A hugely important difference between functional dependency and multi-value dependency is that the other way around compositeness is not the same. So where A determines B and C can be rewritten as A determines B and A determines C, you cannot do the same for A multi-determines B and C. If A multi-determines B and C, then that does not imply that A multi-determines B or that A multi-determines C. That's a separate situation. Now, if we return to the example I gave with Erland being picky about design on Monday, but not being allowed to be that picky, or in this case, being allowed. This is the example where fourth normal form is not violated. So this is a conference where the organizers say, hey, Erland, you're the boss. If you don't want to talk about design on Monday, your call. In that case, expert multi-determines day and subject by definition, because it's all the columns in the table. And I can just look at the name Erland and pick all the combinations of day and subject that are in the table and that are not crossed out. And those are the subject day combinations for that expert. But expert does not multi-determine day. Because if I ask, when can I talk to Erland within the universe of discourse, the answer should be, do you want to talk about tuning or about design? Because if you want to talk about tuning, you can do it on Monday or Tuesday. But if you want to talk about design, it is only Tuesday. And expert also doesn't multi-determine subject, because if I ask you, what subjects can I ask Erland questions about? Well, you'd have to check the day first, because on Monday, the answer will be tuning. On Tuesday, the answer will be, you can talk about tuning or design to Erland. So here, there are no multi-value dependencies between subsets. There's only a multi-value dependency between the entire set, and that's okay. Fourth normal form is not violated. But in the example where we said, hey, this table is wrong, it's a violation of fourth normal form, Erland can bail out on Monday or he can bail out on design, but we don't allow him to be more picky than that. Now, if you look at the table on the left, you will see violations of fourth normal form, because now expert does multi-determine day. When can I talk to Erland? On Monday and Tuesday, regardless of what subject you want to talk about, or after he crossed it out on Tuesday. What can I talk about? Design and tuning, regardless of the day, because the conference organizers don't allow Erland to be picky. So that's the situation where fourth normal form is violated, and it's wrong because in the left-hand side table, there were multi-value dependencies between subsets. That's fourth normal form. Let's move on to fifth normal form. Lewis, unless there's questions?
There are currently no questions.
Good. I know some questions about fourth normal form might come in. People might be frantically typing now. I'll take them then later. So this is the same example I used, but when I talked about this example, I was a bit incomplete. Yes, when I say on Monday you can ask Erland about design, we can infer that on Monday you can ask Erland questions. We can also infer that Erland knows about design. But there's one thing more we can infer. On Monday you can ask about design. Now that may sound a bit weird, but remember, in the universe of discourse, the person paying me is always right. So if this is organized by a conference organizer who says, I do not want anyone to talk about design on Monday, well, frankly, for me, that would be a deal breaker. I would be out and have someone else deal with that. But it's their call. So what if the conference organizers says to everyone in the entire conference, and specifically to all the experts in the Ask the Expert booth, you are not allowed to answer design questions on Monday. Now we suddenly see that it's not only Erland who cannot talk about design on Monday, Oliver is affected by this as well. Oliver also cannot talk about design on Monday. He can still talk about it on Tuesday together with Erland, but not on Monday, because the boss of the conference says, no design on Monday. I don't know why I did that voice. I just had the urge to do a weird voice. Forgive me. Now you can go through this table, and I've did that before. And if you look at the table, you will see that expert still multi-determines day and subject. Expert still doesn't multi-determine day. Expert still doesn't multi-determine subject. And there's 6 more combinations that you can run through. And all of those combinations will reveal the same image. There are no violations of fourth normal form. Even in this case, where on Monday you cannot talk about design, the table as given violates nothing in fourth normal form. It does violate fifth normal form because it's still an anomaly. Remember, the conference organizers disallow design, but the table does allow me to remove one of the 2 rows I should remove. If I remove only there's no slide for it. If I remove only the row for Erland and not that for Oliver, then the table is happy. SQL Server or whatever database management system you use will allow it. And our goal is to have tables that enforce as many business rules as possible. This table doesn't, even though it's in fourth normal form. That's because it's still a violation of fifth normal form. And in this case, it's basically the same idea. For each of the facts that you can infer from on Monday, you can ask Erland about design, we should have a separate table, because each of those facts by itself may be added or removed. Erland can still say, I'm not there on Monday. Erland can still say, I don't want to talk about design at all. And the conference organizer can say, no design talks on Monday. And each of those will now, in those 3 smaller tables, be a single row removal to remove a single fact. And that's what we want. So going to the formal definition, fifth normal form is achieved if your table is already in fourth normal form and there are no join dependencies unless implied by a key. So what's a join dependency? Well, let's return to our table. And let's assume that we have this table, and I know it's a fifth normal form violation, but let's assume I have it anyway. So I have this table. And I'm going to run some queries with distinct and store the results in other tables. So basically, I'm inferring other facts from the facts here. This will be the result. And I'm going to throw away the original table. Done. Truncated, deleted, nowhere to be found. I have no backups. It's gone forever. But I do have the 3 new tables, and I can, of course, join them with the proper join clause. And what will be the result if I join these 3 tables? Hey, hooray, we have our original table back. That's a join dependency. A join dependency means I can break up this in smaller tables, throw away the original, and I'm guaranteed to get back the original when I join everything together. Now, if we allow Erland to be picky and say, I don't want to talk about design on Monday, the conference allows it. I know about it, I'm here on Monday, but I do not want to talk about this specific topic, then there is no join dependency. Because if you look at the table on the left and then work through how it would work out if you split it, you can still get the row with Monday and Erland in this table, because Monday Erland is here. You still get the row Erland design, because he's talking about design on Tuesday. You still get the row Monday design, because Oliver is talking about design on Monday. And if you join the 3 together, you would get Monday Erland design back. But Erland refused to talk about design on Monday. We allowed him that liberty. So now this join dependency is broken and we do not get the original back. If we do remove 1 row in Monday design, we actually remove 2 rows in the join results. So that's the join dependency. And 5th normal form means if there is a join dependency, like you see here, then the table should be broken up. If there is no join dependency, like you see here, then the table on the left side is fine because it's just as it is. We do care about the specific fact that Erland himself wants to talk or does not want to talk about design on Monday. Questions?
Yes, Jennifer asks, I always assumed that one should design a database to be entirely 3NF or 4NF, etc. These business rules you're using as examples indicate that one set of tables may need 3NF and another may need voice code or 4NF. True?
No, false. I'll get in a bit more detail on this later when I talk about, because not all normal forms have the same practical value. I'm switching between different examples because there's not a single example that illustrates all the normal forms. But for every table, you should basically, and I'll come to the exceptions later, but for every table, I would recommend going through all the normal forms. Now, when you talk about 4th normal form and 5th normal form, by definition, those can only be violated if you have a candidate key over 3 or more columns. If you don't have that, then that table can never violate 4th or 5th normal form. Boy's code normal form can only be violated if you have keys over 2 columns. And of course, if you have the habit of just slapping all the columns together, adding an identity and making that the primary key and not thinking anymore, then you're fooling yourself because there's still more candidate keys in the table. You just didn't look at them. And then you're guaranteed to have a bad schema. But if you make sure to find all the candidate keys in your table, then you first go to 3rd normal form. And then if there's 2 or more columns in a single key, look at Boy's code. If there's 3 or more columns in a candidate key, look at 4th and 5th. And the rest that we'll get at now. More questions?
That's all the questions.
Good. Then let's move to 6th normal form. We're getting there. So remember 5th normal form, right? No join dependencies unless implied by a key. There we have such a nasty exception again. Why should we make exceptions? 6th normal form, no join dependencies, period. So what does it mean when a join dependency is implied by a key? Let's look at an example. So here, and I already spoke about a session AD205, depending on the universe of discourse on your needs. It may need to be split in 2 columns, track and session number, or it may be just a single column AD205. In this UOD, 8205 is just the identifier of a session. In this list, for each session, we have a topic, and we have the first name and last name of the presenter. And here again, some UIDs may just have presenter name. This UID has first name and last name as separate columns because they have some logic that requires those attributes to be separate. So a simple list of sessions with their topic and their presenter. Nothing special, a simple candidate key for just a session, and nothing else because there's multiple sessions on each topic, and presenters may have more than one session. Not in the example you see here, but if you have to look at the full list, maybe Oliver Engels does 3 sessions today. I don't know, but so that's not a candidate key either. Now I can quickly go back. I can do 3 selects from here and store the results in new tables. Quite obvious. I think nobody is surprised here. And when I join them, yeah, I get the table back. And probably when you think about this for a few seconds, you will say, yeah, duh, that's obvious because you're joining on the primary key. You're just breaking out columns in separate tables and joining them back together. Because of the key, that's obvious. Or in other words, it's implied by the key. That's what I was going to explain. So this is the type of join dependency where fifth normal form says, yeah, duh, that's obvious. The key already defines that this join dependency is there, and we don't need to break this apart because there are really no business rules that you can violate in the combined table on the left, but cannot violate in the separate tables on the right. So if this doesn't help us with business rules, why is the sixth normal form even relevant? Well, there are people in the database world and most in academic worlds who dislike the concepts of nulls. So let's change a few rows here, and I've highlighted the changes. I have removed a few data points. So apparently we have no information about the topic for sessions AD207 and for session PD203. And we have no information about who talks about backups in DBA 305. Thank you. I just said thank you to someone who talked to me, and I realized too late that that was not on stream. So you are now all wondering, who is he thanking? I'm sorry for that. And it's just such a routine to say thank you. Politeness is a bad habit. This is not true, by the way. Anyway, so we have some nulls in there. And now there are people in the world of database theory who dislike nulls and they say null is a big mistake. I personally disagree with them, but they exist and they do have arguments. So what you do is when you now break the table on the left into 3 subtables, 3 smaller tables, you don't store nulls there. You can simply remove the rows. We have no information about the topic for AD207, so we don't store AD207 null. We gently don't store AD207 in that table. And now, if you look at the right-hand side, you will see that we have a schema that will never contain nulls. That's why those theorists love this design. Cool. But of course, the join dependency means that as soon as you combine the data, you still have those nulls because you have removed the nulls, but you have not removed the underlying problem that not all data is available in the database. And all issues that are attributed to nulls are actually caused by not all data being available. And that's simply a reality we have to deal with. Now, there also is a downside to sixth normal form. In the original table on the left, I can imagine that, and that's of course not a single table issue, but I can imagine that there's another table with all the speakers and that we have a foreign key between the combination of first name and last name to that speaker table. So if in the original table on the left, I try to change the speaker of PD203 to Tim Jones, then I will get a violation because we don't have a speaker called Tim Jones. But if I choose to use sixth normal form, I can change the speaker, the first name of the speaker for PD203 to Tim. And that will be accepted because we have a speaker with first name Tim. The last name is in a different table, and I cannot have a foreign key defined in that complex way. So now, actually, sixth normal form does not offer protection against some problems that we would like to be protected against. Yes, we get rid of the nulls, but the downside is that we also get rid of some business rules. So I personally don't like sixth normal form as a practical thing to do in my database. There is some merit to talking about it on a theoretical level, but don't use it in your database. Now there is optimal normal form. And optimal normal form is not really an academically defined level, but that's sort of an almost sixth normal form, where they say, okay, we need to have this protection for Steve Jones. So we need to have the first name and last name together. So we're not going to break that joint dependency, but we are going to break the rest. So that's basically as close to sixth normal form as you can get without losing other constraints. Optimal normal form is based on fact-based modeling methods such as I'm going to say object. I always know it, and now there's a blackout on what ORM stands for. Object role modeling or natural language information analysis method. It's where they work with fact types, and every elementary fact type becomes a table. End result is mostly sixth normal form, except when foreign keys or alternative keys, composite key columns are used. As far as I know, there's no academic foundation for this normal form. And personally, I think both sixth and optimal normal form is too many small tables, too many joins to actually do something with the data. In our relational current databases, they are not designed for this kind of normalization. There are academics who are working with completely other database engines that try to do something with sixth or optimal normal form, but that's not for our everyday practice. The last normal form is domain key normal form, and I put it last because it's a bit different. It's not based on dependencies, it's based on domains, keys, and constraints. So what do those terms mean? Well, domains are the values that are allowed in a comma. It's like a data type, but a bit more. Data type can be small int, but the domain can be small integer values from 1 to 100, for instance. Keys, that's the candidate keys. We talked about that. And constraints are all the rules that we want to have for valid data. So basically, the business rules. And the domain key normal form says every constraint within the table must be implied by the keys and the domains. And why do we care about that? Well, first of all, as far as known, DKNF implies fifth normal form and lower, probably also optimal normal form, but not sixth normal form, and isn't applied by sixth normal form. But why do we care about DKNF? Well, if we have a domain that's a data type or a check constraint, it's enforced by the database without having all kinds of extra code. Keys also defined in the database, enforced by the database without extra code. All other constraints that are not enforced by domains and keys, we need code. And code is expensive. It has to be written, it has to be tested, it has to be debugged, it has to be maintained. And that's the problem. There's also another problem with DKNF itself. It's sometimes impossible. Let's say that a conference has this rule where they say every presenter delivers at least 3 sessions. Then you can have a table with presenters and sessions, and there's no way to achieve this, to enforce this business rule without doing additional logic, such as having a separate table with an aggregation there. Or it may require extra tables and subtypes and extra logic to get your queries correct, to ensure that the correct rows are in the correct data. So sometimes you need extra code to achieve domain key normal form, which we wanted to get to have less code. Extra code to have less code doesn't sound like a good idea. So I know I'm nearing the end, and I want to quickly recapture. I skipped first, second, and third normal form. We talked about Boyce-Codd normal form, which implies third. Fourth normal form implies Boyce-Codd, fifth and sixth normal form. Then somewhere uncomfortably between third and Boyce-Codd is elementary key normal form. optimal normal form sits somewhere uncomfortably between fifth and sixth. And then there's domain key normal form, which is a bit weird and nice in theory, but not really relevant. I myself always try to achieve fifth normal form for all my tables. Sixth normal form, optimal normal form is not really interesting enough because my engine doesn't work with it. Domain key normal form is a nice theoretical concept, but not achievable in practice. Fifth normal form is achievable except for the few BCNF, impossible BCNF situations. So I always try for fifth. Are there any questions at this time?
Okay, so there are a couple. A composite question. Andrea L says, how do the normal forms perform in a database? Are they fast? How do the higher normal forms perform in a database? Are they faster than 3NF? And then there's a question of, I wonder if there are any trade-offs between making it perfectly normal versus too many tables and joins. Or perhaps is there another way? Has anybody had luck pushing beyond third?
Yeah, like I said, I personally see no reason to ever not stop at third. I always go to fifth. Then there is a secondary consideration, that's denormalization. I always say you cannot denormalize if you don't normalize first. Too many people use denormalization as a term to hide the fact that they're not normalizing at all. But if you first properly normalize all the way to fifth normal form, then say, okay, now I have some practical issues where I run into performance issues for some specific cases, then you can try to fix that. But you need to be aware that if you're not on fifth normal form, you are opening yourself to more violations of business rules. I had examples for every normal form I talked about up to fifth, where if you violated that normal form, you could enter invalid data in the table, and by adhering to that normal form, you made that impossible. Sometimes there is a trade-off where you say, yeah, I know that now I'm opening up to invalid data, but I need this to go faster. That's a trade-off you can make. There is the world of the perfect data model, and then there's the world of the perfect application. But never jump to that conclusion before you have tried the normalized model. Always start there, because I want data to be correct much more than I want my queries to be fast. If my data is incorrect, my results will be fast. And my manager doesn't care about getting incorrect results fast. He cares about getting correct results, preferably fast. More questions?
Okay, we have a few more minutes. Jennifer asked again, for every table, I recommend going through all the normal forms. He said, didn't really answer a question about normal form consistency in the database.
Sorry, can you slow down a bit? Because I didn't get that.
So for every table, this is a quote, for every table, I recommend going through all the normal forms. Mm-hmm. So that didn't really answer my question about normal form consistency in a database. I think about should you try to get all the tables to the same normal form?
Okay, then I will be a bit clearer. Some tables, depending on what kind of candidate keys there are, once they are in third normal form, are by definition already fifth normal form, because boycott fourth and fifth normal form can only be violated by multi-column candidate keys. So if you have a properly designed table where you actually found all the candidate keys and all the candidate keys are on a single column only, then if it's third normal form, it's by definition already fifth normal form. If you have candidate keys that are 2 or 3 columns, I would always do the check on boycott fourth and fifth normal form, just to be on the safe side. Most of the times they will not be violated. But if they are, you do the business a great service by identifying, hey, in this table, the way I've designed it now, someone can make a modification that would violate our business rules. And if I break it up into separate tables, I protect the application against that. So always go all the way. And if all your tables are in fifth normal form, then your design is in fifth normal form. If you need to leave one table in third normal form, then officially you need to say the database is in third normal form. But what I then would say is still say, I have the database in fifth normal form, except for this table where, for specific reasons that I enumerate here, we have chosen to accept a risk because there is a benefit that offsets the risk. I think that's also important to make choices and make sure that people understand why the choice is made.
Cool. I think we have about 20 more seconds left, and that's all the questions.
Okay, then please do not forget to fill out the evaluation. I want to hear what you liked, what you didn't like, and enjoy all the rest that Summit has to offer. And maybe I see some of you tomorrow in my other session, same time, same place. Bye-bye.